Around the 1800s, people across the world began making a remarkable discovery. In remote locations spanning 3 continents, thick, dark oils were mysteriously seeping from the earth itself. These mysterious substances appeared in Canada, across the vast territories of Russia, and in the ancient lands of Iraq. Local people had known about these seeps for generations, but few understood their potential significance. What they discovered were thick, viscous, dark substances oozing directly from the earth. These natural oil seeps created slicks on the surface, covering rocks and soil with a mysterious black liquid that seemed to emerge from deep underground. At this time, whale oil was the primary source of illumination for homes and businesses. However, whale oil came with significant drawbacks. It was extremely expensive, messy to handle, and required dangerous whaling expeditions that could take months or even years to complete. As word spread about these natural oil seeps, forward-thinking individuals began to wonder, could this abundant, naturally occurring substance serve as an alternative to expensive whale oil? The stage was being set for a revolution that would transform how the world produced light, heat, and eventually power. These seemingly insignificant seeps of dark, thick oil would prove to be the foundation of the modern petroleum industry. What started as curiosity about strange substances emerging from the earth would soon lead to one of the most important technological revolutions in human history. In 1859, a pivotal moment in industrial history occurred when Edwin Drake successfully drilled the first commercial oil well in America near Titusville, Pennsylvania. This historic achievement marked the beginning of the modern petroleum industry. Drake's well, reaching a depth of 69 feet, proved that oil could be extracted from the ground in commercial quantities. Drake's success triggered an oil boom that would transform not just Pennsylvania, but the entire world. This single well demonstrated that petroleum could be a reliable and abundant resource. The extraction of crude oil was just the beginning. The real breakthrough came with the development of refining processes that could transform this raw material into useful products. Crude oil refinement became a sophisticated process, separating the complex mixture into different products based on their boiling points and molecular structures. Through distillation, crude oil was separated into multiple valuable products. Kerosene became the most prized product used for lighting homes and businesses before electricity became widespread. Kerosene revolutionized lighting, replacing dangerous whale oil and providing a safer, more affordable alternative for illumination. Meanwhile, gasoline was initially considered a problematic waste product. Its high volatility made it dangerous to handle and store, leading many refiners to simply burn it off or dump it. Drake's oil well had set in motion a chain of events that would eventually transform transportation, industry, and modern life. Though gasoline was initially unwanted, it would soon become the most valuable petroleum product of all. By the mid-1800s, oil refining was producing various products through distillation. Heavy oils, kerosene for lamps, and other useful substances were extracted and sold. But there was one byproduct that refineries considered worthless: gasoline. This highly volatile, flammable liquid was seen as nothing more than dangerous waste to be discarded. However, some forward-thinking inventors began to question this practice. They looked at gasoline's properties with fresh eyes and asked a simple but revolutionary question. What if we used this volatile substance instead of throwing it away? Gasoline was highly combustible, burned cleanly, and released tremendous energy when ignited. This shift in thinking transformed gasoline from a disposal problem into a potential solution. Instead of waste barrels, inventors now saw containers of untapped power. This revolutionary insight sparked intense exploration into gasoline's potential as a fuel source. Inventors began experimenting with ways to harness its explosive energy for practical applications, setting the stage for the internal combustion engine revolution. In 1860, a French engineer named Étienne Lenoir achieved a breakthrough that would change the course of industrial history. He built the first practical gas-powered engine, equipped with an electric spark plug. Étienne Lenoir was a Belgian-French engineer who recognized the potential of gas as a fuel source. Unlike previous attempts at gas engines, Lenoir's design included a crucial innovation that made reliable ignition possible. Here is Lenoir's revolutionary gas engine design. This technical drawing from his patent shows the key components that made his engine the first commercially successful internal combustion engine. The key innovation in Lenoir's engine was the electric spark plug. This allowed for reliable ignition of the gas-air mixture at precisely the right moment, something previous engines struggled to achieve consistently. Let's see how Lenoir's engine operated. Unlike modern four-stroke engines, Lenoir's design used a two-stroke cycle with no compression of the fuel mixture. First, the gas-air mixture enters the cylinder through the inlet valve. Notice that unlike later engines, there is no compression stroke. The mixture enters at atmospheric pressure. Next, the spark plug fires, igniting the gas-air mixture. This creates a rapid expansion of hot gases that pushes the piston down with considerable force. Finally, the exhaust valve opens and the spent gases are expelled from the cylinder. The piston then returns to its starting position, ready for the next cycle. However, Lenoir's engine had a significant limitation. Because it did not compress the fuel-air mixture before ignition, the combustion was relatively weak and inefficient. This lack of compression meant that Lenoir's engine achieved only about 4% efficiency. Despite this limitation, it was still revolutionary because it was the first gas engine that could run reliably for extended periods. Lenoir's gas engine marked the beginning of the internal combustion engine era. While it would soon be improved upon by other inventors, his spark plug innovation and reliable operation made practical engine-powered machinery possible for the first time. The Otto cycle is the fundamental operating principle behind every gasoline engine. This four-stroke cycle converts fuel into mechanical energy through a precisely timed sequence of events. First is the intake stroke. The piston moves downward, creating a vacuum that opens the intake valve. The air-fuel mixture is drawn into the cylinder, filling the combustion chamber. Next is the compression stroke. Both valves close tightly, and the piston moves upward, compressing the air-fuel mixture to about 1/10 of its original volume. This compression heats the mixture and makes it more explosive. The power stroke is where the magic happens. The spark plug fires, igniting the compressed air-fuel mixture. The explosion creates tremendous pressure, forcing the piston downward with great force. This is the only stroke that produces power. Finally, the exhaust stroke completes the cycle. The exhaust valve opens while the piston moves upward, pushing the burnt gases out of the cylinder. The intake valve remains closed during this process. This four-stroke Otto cycle repeats continuously in every cylinder of a gasoline engine. The precise timing and coordination of these strokes, multiplied across multiple cylinders, creates the smooth power delivery that drives modern vehicles. This fundamental principle, perfected by Nicolaus Otto in 1876, remains the foundation of internal combustion engines today. Otto's four-stroke engine sparked a revolution in mechanical engineering. Following his breakthrough in 1876, several brilliant inventors made crucial contributions that would transform transportation forever. In 1885, Wilhelm Maybach revolutionized fuel delivery with his invention of the carburetor. This device mixed air and fuel in precise proportions, making engines more efficient and reliable than ever before. Also in 1885, Gottlieb Daimler created the first truly compact internal combustion engine. Unlike the massive stationary engines of the time, Daimler's design was small and light enough to power vehicles. In 1886, Carl Benz achieved the ultimate goal. He created the first practical automobile. His three-wheeled patent motorwagen was the world's first true car, powered by an internal combustion engine and capable of carrying passengers. Finally, in 1902, Robert Bosch perfected the spark plug for commercial use. His reliable ignition system made engines start more easily and run more smoothly, becoming an essential component that we still use today. These four innovations, developed within just 17 years, transformed Otto's stationary engine into the foundation of modern transportation. Each invention built upon the previous ones, creating the complete system needed for practical automobiles. 300 years of human innovation, countless trials, failures, and explosions have led to this moment. The birth of the modern engine represents the culmination of centuries of mechanical ingenuity. The steam engine was humanity's first attempt to harness mechanical power. These massive machines used coal and water to create the steam that would drive pistons and turn wheels. But steam engines were massive, inefficient, and dangerous. Engineers needed something smaller, more powerful, and more reliable. The discovery of oil and the development of internal combustion would change everything. The modern engine was born from the perfect combination of four critical components. Each one was essential, and together they created the foundation of all mechanical engineering that followed. The spark plug provides the precise electrical ignition needed to start combustion at exactly the right moment in the engine cycle. The carburetor creates the perfect mixture of fuel and air, ensuring optimal combustion efficiency and power output. The piston converts the explosive force of combustion into mechanical motion, transforming chemical energy into usable power. The combustion chamber contains and directs the explosive force, ensuring maximum efficiency and safety in the power generation process. This is how the four-stroke cycle brings these components together in perfect harmony. Intake, compression, combustion, and exhaust. A dance of mechanical precision that powers our modern world. This engine became the foundation of modern mechanical engineering. Every car, motorcycle, generator, and machine that followed built upon these fundamental principles established over 3 centuries ago. This is El Hadra Mécanique, going back to the mechanical roots. Before the age of wires, circuits, and computer scanners, there was pure mechanical ingenuity. Understanding these fundamentals is essential to appreciating how far we've come.